Here in 1.7, we are going to be talking about graphs of functions in general. And we are going to discern them from even and odd types of functions. So first, let's start off with our even functions. Our even functions, they are symmetrical with respect to the y-axis. So if they, we are graphing them, they are symmetrical to the y-axis. That means you can fold it in half, and it should look just like the same on the other side. So if I drew a line here, for example, a parabola is an even function, and if we folded it right down the middle on the y-axis, it should match, the basic form should match the other side. Other even functions, remember our exponents determine our even functions. So different examples being our x squared, x to the fourth, and so on that way. But also cosine of x is an even function. So then secant of x have to be an even function. Anything to the even exponent. And finally, absolute value is also an even function. What does that mean for even functions algebraically? Since they are symmetrical on the y-axis, you can fold them in half. Doesn't it make sense that our x this way and our x that way will have the exact same y values? So algebraically, our f of negative x, right, should equal f of x, because the y values are going to be the same regardless of going forward or going backwards. That means x of y, if it is an even function, that must then also mean negative x must also equal the exact same y. Next, let's talk about odd functions. Our odd functions here, they are symmetrical to the origin. What that means is that if you took an odd function and you rotate it 90 degrees, it should line up just perfectly. Examples of odd functions are linear functions, right? Our line is an odd function. Anything with the x to an odd integer, so x to the third, x to the fifth, etc. Our tangent of x is an odd function, and sine of x are also odd functions, and their inverses. So cotangent of x and cosecant of x are also odd functions. For an example here, if I drew a quick picture of an odd function, let's move this down just a little bit. If we had, let's say, a cube root here, notice if we rotated this part here and we moved it 90 degrees this way, it would land right here, just like that. That means algebraically that means f of negative x, right, is the same thing as our negative x. So what our negative x should be our negative y, which means if we had x of y, then if we had the coordinates x of y, say we have 1, 2, then we should also have those same coordinates negatively. So negative x and negative y also. Every single function also follow the exact same of rules. First things first, let's say if we had a function and it was multiplied by an integer on the outside. The integer, if it is greater than 1, makes the function skinnier or steeper, meaning it goes or thinner. So let's work with our basic function, our absolute value. Let's say absolute value of x. If it was multiplied by 2, I know that it makes it thinner. It's going to be our basic one, but now the slope kind of goes up 2 over 2 instead of just our regular being 1. We can check this with our coordinates, right? If we plugged in 1, it would be 2. If we plugged in 2, it'd be 4, and so on. And since this is an even function, we know it has to mirror the y-axis, and it looks like this. However, if that integer in front of that x is negative, then it flips the whole thing upside down. So if we had a negative absolute value of x, this is a little review. Remember, it would be normal absolute value, but it just gets flipped upside down here like so. And if we, let's say we added a simple number on the outside, then it either moves it up or moves it down. So if it were the absolute value of x, let's say minus 4, then it's the basic function going down 4. So 1, 2, 3, 4, starting here. It's still going up. It's the basic one going up like so and so. Now, well, let's try something a little bit more complex. What if we had on the inside then and a value? So let's say we had negative x minus 1, right, on the inside. Well, I know what first. This is flipped upside down. So it's a basic one flipped upside down, and it's moving to the right one. So I'm just going to start off here, moving to the right one. I'm going to put a dot for my starting point, and it's going to be flipped upside down. So just graph it like so, with a slope of 1 for the absolute value, and that is how we would change, and every single function follows the exact same rules.